In Monet database, we can use all of these data types to store text. We can name our data type by using their full names, or we can use all of these aliases. And if we want to store just one letter, in that case, we would use this data type. If we want to store a word with fixed length, in that case, we would use this data type. Now, if we store here a word that has less letters than length, in that case, such word will be padded with spaces. But when we read that word from the database, we will only read letters. So spaces are only to store such word inside of our database. If we want to store text of variable length, in that case we would use varchar. If we want to store a lot of text, we would use club, that is character large object. And if we want to limit that club to some number of letters, then in that case we would use this data type. Now let's see all of this in practice. We will jump here to our terminal, and first we will create one table. So I will just copy my code here. So we will create a table that will have a column with char data type with fixed word length. In this case, we are using only word with 2 letters maximally. We can use varchar. We can create one club and one club with limited length. I will execute this code, and then I will enter some data inside of these columns. I will use this code here. I will click on enter, and we can now read from our table. So I will say select, start from our table text, and this is our result. Now, if we try to break our data type, if I try to use this code here, in this case, I'm trying to enter these 3 letters inside of this column that can only accept a word up to 2 letters. In that case, we would get an error message, and here is that error message. I will now clear my screen. If we want to store an image or some file inside of Monet database, in that case, we should use binary large object. Now we have a blob or a blob with limited size. We will go now to terminal, and first I will create one table with blob columns, and this will be a code for that. And then I will enter some data inside of our table. Let's say this data here. Now I will not actually use some images or files. I will just use these letters and these numbers. I will now click on enter, and now we can read from our table. If we use select star, we will get our result. But if I do something really similar, for example, if I try to enter this data inside of our table, so the only difference now is that I have this letter G. This will fail. And this will fail because these are actually not letters and numbers. All of these are hexadecimal digits. Hexadecimal numbers can have one of the 16 digits, and those digits are represented with numbers 0 to 9 or letters A to F. So G is not acceptable. And similar to that, there is one consequence. If I use this code here, this will also fail. And the reason for that is because here I have an odd number of characters, but number of characters should be even. Why is that? Well, if this character here is representing one of the 16 digits, and this character here is representing one of the 16 digits, then together they're representing 16 times 16 combinations, that is 256 combinations. And as we know, 1 byte can represent one of 256 combinations. So in this case, to represent 1 byte, we always need to have 2 characters, and that means that total number of characters should always be even. So if we try this same code but with even number of characters like this, this will succeed. And now I will clear my screen. If we want to store some integers inside of our Monet database, in that case we should use these data types. So first we have Boolean. Boolean can be true or false, or that is actually 0 or 1. Then we have tiny integer, small integer, integer, big integer, and huge integer. And difference between them is because the bigger the integer, the bigger number it can have. For example, a tiny integer is limited only to 127, a small integer is up to 32,000, integer is up 2 billions, and big integers and huge integers are really big numbers. Let's now go to terminal, and first we will create our table. So we will create table with integer data type columns, and then we will enter some data inside of those columns. We can now read from our table. So let's start from integers table, and we can see results. So this is Boolean, this is tiny integer, small integer, integer, and these are big integer and huge integer. Now, we don't have to use true or false for Boolean. We can also use 0 or 1. So, for example, if I try to enter one row of data like this would work. And if we now read from our table, this would be result. This time we have false, and the reason for that is because we have used 0. I will now clear my screen. If we want to store decimal numbers in Monet database, in that case we should use decimal data types. And these decimal data types can use arguments. Those are precision and scale. Now, if we look at this number here, this number has 3 digits on the left side of decimal point and 2 digits on the right side. In this case, precision is 5 because we have 5 digits at total. We have 3 blue digits and 2 red digits, but the scale is only 2. Scale is for a decimal part of a number. So that is definition of precision and scale. And when we are defining decimal numbers, we can use default values. In that case, we are using decimal data type. Precision is then 18 and scale is 3. But we can also use this data type. In this case, precision is defined by us, but in this case, scale is 0. So there will be no decimal digits. And we can also define both precision and scale. Now we can go to our terminal. And here we will first create one table using this code here. And then we will enter some data inside of our table. We can now read from our table. And this is our result. Now, in this first case, we are using default values for precision and scale, and default value for scale is 3, so we have 3 digits on the right side of decimal point. In this second case, we don't have decimal digits, so instead of getting 1.2, we only have 1, and this could be dangerous, so we should be careful when entering decimal numbers, because we can lose some decimal digits. And in the case that when we define both precision and scale, we can enter something like this. I will now clean this screen. Beside integers and decimals, we can also use floats. For floats, we can use real data type, we can use double, or we can use float with precision argument. Now, what's special about floats is that they are not capable to store any value. In that case, they would round a number a little bit. So these are actually approximate numbers, but their virtue is that they can be stored by occupying less memory. So they are less memory hungry, but we pay a price that they are just approximate numbers. Double number is much bigger than a real number. And also this float data type is a special kind of data type because it is not using a precision defined like this. Instead of that, it is using some special kind of precision that is called binary radix 2 precision. This precision can be only between 1 and 53. And in this case, float 24 is the same as a real data type, and float 53 is the same as double precision. Let's now see how we can enter some dates and times in Monet database. And for that, we would use these data types. For dates, we have date data type, and then we would use this syntax. But for time, we would use the syntax with hours, minutes, and seconds. Now, we can combine time with precision We can also combine time with time zone, or we can use both. So we can combine time with precision and time zone. In the case of time, precision is defined as fraction of a second. For example, for this many seconds, we have 4 digits after decimal point, so precision in this case is 4. And precision has to be numbered between 0 and 6. And if we are using this to express fractions of a second, then our syntax would be like this. We can also express time zone for our time, and then we would use this syntax. And of course, we can combine these two syntaxes to get something like this to express both precision and time zone. Let us now go here to terminal, and we will, like always, create a new table where we will use this date and time data types. And then we will enter some values inside of our table. And we will read from our table. And everything is as expected, except in the columns which have time zone. Here we have this time zone, and 3 hours and 15 minutes is the time, but here the time is 2 hours and 15 minutes, and time zone is different. So why is this happening? Well, let's say that I'm currently in Romania. In Romania, this is a Romanian time zone. And if I look on my watch, I would see this time. But I'm currently in Serbia, not in Romania. So my time zone is like this. And if I look on my watch, I would see this time. So at the same moment in the universum, a Romanian watch would show this time, and in Serbia it would show this time, because we are using two different time zones. I will now clear this screen. We do not have to use dates and time separately. We can combine them. In that case, we would use timestamp data type. Timestamp can be with precision, so we can define precision, can be combined with time zone, or we can use combination with both precision and with time zone. If we don't define precision, in that case, we would use default precision, and that would be 6. Now let's go here to our terminal, and we will now create a new table. So I will copy this code here, and then we will enter some data inside of our table. So we will use these values here, and then we will read from our table. So let's start from date time table, and this is our result. Now in this first and this third column, we are using precision 6. So we have 6 digits here, and we also have 6 digits in here. But in this second column and this last column, we have precision just 3. So we are using 3 digits, these 3 digits, and these 3 digits here also. We can also notice that there is change in our time zone. Here we have 18 hours and 2 minutes, but time zone is plus 2 hours. But that will be transformed to a different time zone, plus 1 hour, because currently I'm in Serbia. So this time will be 17 hours, and it is the same thing here. So instead of time that would be, for example, like this in Romania, we have time like this that is valid in Serbia. I will now clean the screen. Besides using time as a reference for a moment in time continuum, we also can use intervals. Intervals are periods between two moments. And for intervals, we are using two measurement units, either months or seconds. If we are using months, then we can express those months with years, with months themselves, or we can use some syntax like this one. In this case, 3 is for years, 1 is for months, and 1 is for days, but these days will be ignored. And if we copy this expression from here, if we place it inside of our terminal, we would get our result like this. So 3 years are actually 3 times 12, that is 36. 36 months is just 36. And this time we have 1 month more, so the result is 37. And these intervals here, they're actually data types, so we can create a new table with such data types. So we can use this code here, and then we can place some data inside of that table. So I will use this syntax here. And now we can read from our table. So select start from intervals table will give us the same result. Again, we have 36, 36, and 37. I will now clean my screen. I said earlier that besides using months as a measurement unit for intervals, we can also use seconds. And if that is the case, we can use any of these data types here. For example, we can express our interval in days, or we can be more precise. So we can say this much days and hours. We can also combine days, hours, and minutes, or we can even add seconds. And it is similar for hours. We can have pure hours, we can combine hours and minutes, or hours, minutes, and seconds. We can have pure minutes, or we can combine them with seconds, and we can have just the seconds. But if we copy this expression in our terminal, in that case, we would get all of the results in seconds. So 1 day is this much seconds. If we add one more hour, in that case, we have 3,600 seconds more. We can add 1 minute, so we have 60 seconds more. And then we can also add some seconds, so we have 1.33 seconds more in this case. And it is similar for hours, minutes, and so on. I want now to talk some more about time zones. And for that, I will use one example. So I will create one simple table that only has one column of type time with time zone. And I will enter one value inside of that table. And now we can read from our table. And as previously, Monet will change the time. So this local time will be changed to this local time, and time zone will be also changed. But what if I don't want to use this time zone? What if I'm not in the same country as a server? In that case, I would like to change my time zone. And for that, we have a statement. So statement is something like this. Set time zone interval to 2 hours. So I will change my time zone. We can also set time zone to negative value, because if we are on the other side of a Greenwich, then we would need a negative time zone. And we can use any of intervals. For example, here I will use hour to minute. So now I have set my time zone to 2 hours after Greenwich. And if we now read from our table, we would not get 14 hours, but we would get 15 hours. That is the same time as it is written inside of our table. So we have written 15 hours, and that is now the result. So we can change our time zone if we want to. And then if we want to know what is our current time zone, then we should use this expression, select current time zone, and we would know that our current time zone is 2 hours, but it is always expressed in seconds. And I want to tell you one more thing. When we are looking at these two times, what are they presenting? They're presenting the same thing. They're presenting the Greenwich time. So what is the Greenwich time in this case? It is 13 hours. It is 14 hours minus 1. In this case, it is 15 hours minus 2. So in both cases, this is a time of 13 hours, 16 minutes by using Greenwich time. So they are expressing the same time. And that Greenwich time is something that will be written directly to database. But when we read it, we have to specify our time zone. And based on that, Monet will calculate our local time.